Hello world, it's Rahul. Welcome back guys to machine learning tutorial. So guys, let's quickly recap the last session where we have understood the basic concepts of linear regression model, how to draw best fit line and how to code as well with and without using scikit-learn library. So today we'll be discussing gradient descent. Now as we already have an equation of y hat is equal to mx plus b, we can directly calculate error by subtracting y hat value from actual y value that we have already seen in last session. So guys, here we'll make use of cost function that you can see on my screen highlighted in red. And this is nothing but the summation of loss function, that is square of error value. That's it. Sometimes we call it as mean square error as well. And guys, just to add one more thing, that in this equation we are dividing the cost function by 2 only for ease of our calculation. Okay, so we are agreed that our goal is to minimize the cost function. But what do you mean by minimizing the function? So let's quickly understand this with one example. If you can see my screen, you will find out that something is equal to something. And if I write a function in general, that is y is equal to x square, then we can create a Cartesian against this as shown in figure. So guys, minimizing the function is to actually find the x value that produces the lowest y value. And for minimizing this function, we need to find out minimum in this Cartesian. And for that, we'll be using gradient descent. So let's quickly understand what is this gradient descent. So guys, let's say we are at brown point right now and we are supposed to walk along with the graph. So here our questions will be like, in which direction should we move, or should we take big step or smaller one? How did we do that? So if I draw a slope at brown point, we can see that if we go into upward direction, then we'll be far from minimum. So what should we do now? We should go to down to converge the model. And slope at blue point is less steep than that at brown point. This is the slope that defines how far we have to travel to reach the minima. So guys, idea of this computation or derivation of this function tells us how to search and find the path. Now let's find out the derivative of this cost function. Guys, let me rewrite the equation as j of m and b equal to summation of square of error, as we already know that error is nothing but y hat minus y value. Guys, just to add one thing, we have stochastic gradient descent and batch gradient descent. And if we see the difference, then the batch gradient descent computes gradient using complete data set, whereas stochastic gradient descent computes gradient using single sample. So guys, here we are going to use stochastic gradient descent only. And as we have discussed that error is nothing but the combination of m and b values, so we can tweak these values by subtracting derivative of m and b from actual m and b value. So guys, as we already have m and b parameters with us, now we can find out the derivative of j in regards to both m and b value. And we'll see how this j change when m changes. Guys, before going ahead, let me tell you that here we have to use some calculus concepts. So if you don't know the basics, just have a look once. Otherwise, I'll try to make you understand little bit of it by using some examples. Okay, so for this derivation, we have to use power rule and chain rule, and combination of both is partial derivation. So guys, let's quickly understand what does power rule say. Now suppose we have a function that is f of x is equal to x power n. So power rule says that we'll multiply power with x coefficient and subtract it by 1. So it will become n into x to the power n minus 1. So guys, by using this knowledge, we can say now that delta of j over delta of m will be twice of error. So guys, here we also need to find chain rule. So suppose we have a function like y is equal to x square, and we have another function that is x is equal to a square. So what chain rule says that If we want derivative of y relative to a, what we have to do is we have to find derivative of y relative to x, that is twice of x, and then multiply that by derivative of x relative to a, that is 2a. And that's what we'll be using for our cost function, that is derivative of error relative to m, and that is nothing but the delta m value. So guys, let me quickly calculate derivative of error for you right now. So as we already know that error is mx plus b minus y, where mx plus b is y hat value. So in this situation, x, b and y will be our constant, as we have to look only into m value. So derivative of this will be 1 into x into m to the power 0, which means x. So we can write it as error into x. Then we'll take this and multiply it by learning rate, that is error into x into learning rate, so that we can specify the step size as well to the algorithm. Same we'll do for finding derivative of j relative to b, and we'll get it as error into learning rate. So guys, just to add one thing over here, that derivative of constant will always be 1. Now as we have delta m and delta b value with us, we can directly put these values in equation. M is equal to m minus delta m and b is equal to b minus delta b to generate best fit line. Now let me quickly take a random data for solving gradient descent and generating best fit line on that. So guys, here we have a data set on which we have to find y is equal to mx plus b. If you can see the table, we have x is equal to 1 and y is equal to 2 for row 1. Let's assume the value of m and b as 0.0 and learning rate as 0.01 for as of now. Let's substitute these values to equation y hat is equal to mx plus b. So we are getting y as 0.0. Quickly let's calculate error as well. If we'll subtract y hat from y value, then we'll get it as minus 2. So we already find derivative equation for both m and b, that is m is equal to m minus error into x into learning rate and b is equal to b minus error into learning rate. So after substituting these values, we'll get both m and b as 0.02, as you can see on the screen. Now iterate this process for each row and we can add some epoch value as well. So guys, let's quickly code this to get the best fit line. First let me import pandas and matplotlib libraries for our function, and here I am going to read the data from CSV file. So guys, if you can see my screen, I have written all formulas over here so that this can give you more insights. Okay, as I told you earlier, I have initialized the m and b value with 0.0 and learning rate as 0.01. So this piece of code will iteratively run 5 times, as we are setting our epoch value as 5. You can change it also according to your use case. So here my y hat value will be m into data point from x column plus b, and same we can calculate error, that will be y hat minus data point from y value. And guys, just a quick note that here I'm appending these error values in a list to use it later for drawing error progression. Okay, so till now everything is fine. Now we'll calculate m and b with the formula m is equal to m minus error into data point from x column into learning rate. And for b, b is equal to b minus error into learning rate. So let me execute this to show you the outcome. Perfect. So we can see that first thing, it's giving result for first 5 rows and then iterating through this process by 5 times to get the optimized value of m and b. So now we'll plot curve of error to check whether it is reducing or not by simply passing the error list to plot function, what we have appended in above cell. So guys, now we have both optimized m and b values, that is 1.314 and 0.39. So now we can predict the output based on these values. Guys, now by passing x, y and y hat values to plot function, we can see the best fit line over that scattered data points. Now we can converge this more by tweaking m and b parameters as well. Thank you guys for your time. Do like, share and subscribe. Hit the bell icon to get the latest updates. Happy learning and stay safe.